Lesson 11 is on kinetic energy. And kinetic energy, as we recall from the last lesson, is energy of movement. So if you're looking at the pictures here, there's one guy speed skating, I think that is, dancing, backflips. Or kinetic energy is not just energy of movement of people, it's also just energy and movement of anything. So it can be another animal, it can be a specific object or item. So remember, energy is the ability to do work. Kinetic energy is the energy that's in moving objects. Now, what we're going to use this for in physics is to calculate the amount of kinetic energy there is in something while it's moving. Now, it depends on two things: the mass of the object and the speed of the object. So in the kinetic energy formula, we need to know what the letters represent. The E represents the energy. The K is telling us that that's kinetic energy. The M is representing the mass, and it's important to know that the mass is measured in kilograms. If it's measured in something else, or you're given the mass in grams or some other form, you need to convert it. Now the V represents the speed. And again, it's important to know the speed must be in meters per second. Okay? If you're given the speed in kilometers per hour, you need to use your converting skills and convert it first. When you're doing this mathematical equation, you can use this formula that we see here, or you can rearrange it into a couple different forms, and all of these work. The formula at the top is the one that you've already seen. That's the one that was on that page there. The second one, instead of putting 1/2 as a fraction, I've just changed it to 0.5 as a decimal, and if that's easier for you to calculate with, please, you're more than welcome to use that one. Now, the last one is the one that I like the best because you don't have to worry about fractions or decimals. It's just mass times velocity squared divided by 2. Now, I'll be using the last formula when we're doing our calculations and practice questions, but if you'd like to use the first or the second formula, it doesn't matter. As long as you're using it correctly, you should come out with the same answer. So, how does something get its kinetic energy? If we're looking at each of these pictures, each of these different pictures represents kinetic energy, energy of movement, but where did they get the energy from? In the case of the people or the cheetah, they're getting their energy from the fuel source that they have, or food. In the case of the motorcycle, the machine is getting its energy from the fuel. Now, I also found this cool thing. It's also a charger that you can buy, but it's found in your shoes. So what happens here is that as you're walking, wind goes into the shoe. The wind will actually force the fan to turn. That puts energy into the generator, and then that energy goes into a battery and you can charge your phone with your shoes. So in this case, the kinetic energy from the movement, again, came from the person, so came from the food that they ate. So how does something get kinetic energy? It comes from the potential energy that was initially stored, or it's the transfer of mechanical energy from one object to another. So in this case here, the potential energy, this weight, is hanging from a rope. It has gravitational potential energy, so it has the potential to fall and do work on something else. So as the rope here is cut with the scissors, that weight drops onto, I think this is, I guess, is a post, and it drills that post farther into the ground. The work that's been done, or the energy, is transferred from this weight to the post. Work. Force times distance, and the units that we represent work is joules. Now, if you look at the energy formula, energy is also represented by joules, so work and energy can be used interchangeably. For our first example is recognize what we have in our equation. So our mass we want to make sure is in kilograms, and it is, so we don't have to change anything. Okay. Our bird is 1.2 kilograms. It's our eagle flying at 6.50 meters per second, which is our velocity. And it says, what is the kinetic energy of the eagle? So we write down what we have. Our energy is what we don't know. We know our mass, and we know our velocity. So if we write down our equation, mass times velocity squared divided by 2. Now remember that you can use any of these following formulas to answer this question because they're all the same, but use the one that makes the most sense to you. Now I'm going to use the one that I have here. If you want to use a different one that makes more sense for you, absolutely fine. So we have our mass, we have our velocity, we have to substitute in what we have. So 1.20 times 6.50 squared divided by 2. Now, when you are doing these equations, the very important thing here is that you need to do your squaring first. Okay, this is the part that you have to do first. Okay, if you remember from math, BEDMAS, okay, brackets, exponents, division, multiplication, addition, subtraction. We have here, our squared is an exponent. So that means we have to do that part first. Okay, 6.5 times 6.5 is 42.25. Okay, 1.20, we haven't done anything with that part yet, times 42.25 divided by 2, and we're going to end up with 25.35. Now, this isn't our final answer yet. We need to change this into significant digits. We started off, we have 3 digits that are significant with our mass. We also have 3 numbers that are significant with our speed. So our answer can only have 3 significant digits. Okay, so the 2, the 5, and the 3. Now, our next number here is 5, so we're going to round our 3 up to a 4. So our final answer here is going to be 25.4 with our units, which are joules. Now we're going to try out another one, do the exact same thing here. Now the dolphin swims at 13.5 meters per second. Meters per second is a speed, so that's going to be our speed here. The dolphin has a mass of 65 kilograms. That's going to be our mass. What is its kinetic energy? So that's the part we don't know. So we write down what we've got. Okay, we don't know our kinetic energy. Our mass is 65 kilograms and our speed is 13.5 meters per second. So we're going to write down our formula. Remember with these questions, you get 3 marks allocated. 1 for the formula, 1 mark for the work, and 1 mark for the answer with correct units and in significant digits. So if we substitute in our numbers, 65 times 13.5 squared divided by 2. Now remember, you need to do this part first. You have to do your squaring first, or else it will change your number to something incorrect. So 13.5 squared is 182.25. We bring down the 65. We haven't done anything with that yet, or the divided by 2. We do the rest of the math for this, and we end up with 5,923.125. Okay, now again, we're not done yet. Our 2 numbers that we are given, our mass has 2 significant digits, our speed has 3 significant digits, so our answer can only have 2 significant digits because that's the least number that we have, or that we're given. So we're going to end up with a 5 and a 9. Okay, so our final answer, after we reduce it down, is going to be 5.9 times 10 to the 3rd joules. We know how to solve for the kinetic energy. If we have the mass and we have the speed, you just plug your numbers into the equation and then do the math, right? So, but what if you're given the amount of energy and the mass and you need to find the velocity or the speed? Or what if you're given the speed and the energy and you're trying to find the mass? Well, you're going to have to rearrange the equation or substitute your numbers into your equation and then rearrange afterwards. I'm going to show you the 2 ways to rearrange these equations, and so I can show you what the rearranged equations look like. and then we'll try out an example. Okay, so if we're trying to solve for velocity, again, when you're rearranging your equations, you want to use opposite operations. Okay, opposite operations means that if it's currently being multiplied, you do the opposite, which would be dividing. Okay, so the opposite of multiplying is dividing, opposite of adding is subtracting, and the opposite of squaring something, like with our v, is square rooting. So we're going to start with our first one here. So we're going to solve for speed. Okay, so we have our energy, our kinetic energy, our mass, and the 2 that we have to move around first. Right now, the 2 is being divided, so you have to do the opposite. We're going to times by 2 to cancel those out. What we do to one side, we must do to the other. Okay, so we end up with 2 times your energy equals your mass times your speed squared. Now we're going to get rid of the mass. So we're going to divide by our mass. That cancels those 2 out. What we do to one side, we must do to the other. And we end up with 2 times our energy divided by mass equals your speed squared. Now the last thing we have to do is we have to get rid of this right here, our squared part. The opposite of squaring is square rooting. Okay, that's this symbol. It looks like that on your calculator. So to get rid of the 2 on the right, you're going to square root your speed. What we do to one side, we must do to the other. So the formula to solve for speed looks like this. The square root of 2 times your energy divided by mass. And again, in this case, after you've put your numbers in, please do your multiplying and dividing first, and then square root your final result. Now, if you're trying to solve for mass, you're going to rearrange it the exact same way. Okay, so we want to solve for this right here. Okay, same thing, we're going to start our 2. It's the same as on the other side. Right now it's being divided by 2, so we're going to do the opposite of dividing. We're going to multiply by 2. That cancels these out. What we do to one side, we must do to the other. 2 times your energy equals mass times speed squared. Now we want to move our speed to the other side, or isolate our mass. So right now, v squared is being multiplied to our mass, so we're going to do the opposite of multiplying. We're going to divide. We can take the whole thing. We don't have to worry about separating the v and the squared. What we do to one side, we must do to the other. And so we end up with mass equals 2 times your energy divided by speed squared. And again, please do your speed squared first, and then complete the 2 times energy divided by that answer. Now let's try it out on the next slide. So for this one, we've got a snow kayaker. We have a combined mass of 90 kilograms. Okay, so we're 90 kilograms right here. That's our mass. That's what we're given. And we have 2,531 joules. That's our energy. So the part we don't have is our speed, or our v. So let's write down what we have. The amount of energy that's here is 2,531. The mass is 90.0, and we don't know what our velocity is. So we need to take our equation and rearrange it, or you can substitute these numbers into your regular equation and solve that way. I'm going to do both to show you what they both look like. Pick the one that you feel works the best for you and do it that way. So first, I'm going to rearrange the equation. So from the previous page, we already have it rearranged, or you can do it on your page as well. So the speed equals the square root, your energy times 2 divided by your mass. We'll substitute our numbers in. Okay, the square root of 2,531 times 2 divided by 90, and we square root the entire thing. So that's the part we're going to do last. So we do the multiplying and dividing first. Okay, square root of 56.24, and I put a repeat sign on top of the 4 because the number is repeating. I don't want to round it quite yet till we're very done. And our answer that comes out of this, 7.4996. Now, we have 4 significant digits when we're given our energy. We have 3 significant digits when we're given our mass. So we need to only have 3 significant digits in our final answer. And you'll notice that we have 7.49. Our next number is 5 or higher. It's a 9, so we need to round our last number up, which then it's going to make our next number round up. So our final answer here is going to be 7.50 meters per second. Now, that was the first way to solve this. I'm also going to solve this same equation using just the regular formula and moving things or rearranging things around. Do whichever you feel more comfortable with. So we've already recognized that we have our energy and our mass, and we need our velocity. So for our first mark, we write down our formula. Okay, so our formula is on the board. Then what we're going to do is we're going to substitute our values in, and now we can rearrange our equation as our numbers are already in. So we do it the same way as when we were rearranging an equation. Okay, times this side by 2. What we do to one side, we must do to the other. Then we divide by 90. On your right, what we do to one side, again, we must do to the other. So 5,062 divided by 90 equals 56.24, and the 4 is repeating. We need to get rid of this squared. So what we're going to do is square root that to get rid of the squared. What we do to one side, we must do to the other, and we end up with the same thing. And rounded, that comes out to 7.50 meters per second. Okay, so when you're solving these equations, please do it in the way that you feel most comfortable. But we need to see a formula, we need to see the work, and we need to see the final answer with correct units and significant digits.